Nickel.
So we're looking at programming design tools. All right. So what are some of the programming design tools that we have again now? Anybody remember? Whenever you are making up, when you're writing in the program, you have to have what is known as program design tools, and you have several tools that you use to check the system and check the program to see if the program is running the way or it is intended to run. What are some programming design tools? Anybody remember? Oh, no, my mic was off. Sorry about that. Yes. So we are looking at programming design tools. Anybody remember what are programming design tools?
I guess you talked about it in the last class.
All right. What are they? I talked about it in the last class. What are they again? You have any idea? You remember? Remember what are programming design tools? What are some of them? Give me some example.
PyCharm.
No, Python is a programming language.
Not Python, sir. PyCharm.
PyCharm. All right. What do you use PyCharm to do?
Sir, whenever I'm doing my programming, well, that's the tool I use.
Okay, and what do you doing that tool? What do you use that tool to do?
That's what I use to type in that's what I use to type in all my codes.
And when you type in your code in that do you run it and it compile and work?
Yes, sir.
All right. So PyCharm.
Sometimes if that don't work, I go online and use another tool. I don't remember the name.
All right. Let me just share something else with PyCharm. All right. So you see this PyCharm now. Let me tell you what PyCharm is. All right. All right. So PyCharm is an integrated. Hold on. Let me just go back to this. So the PyCharm is an integrated development environment used for programming in Python. It provides code analysis, a graphical debugger, an integrated unit tester, integration with version control systems, and supports web development with the genre. PyCharm is developed by C-Check company, JetBrains. All right, so what PyCharm is? Evaluate can use PyCharm. The developing tool that I'm looking for, programming developing tool that I'm looking for, are the most popular ones that no matter what, because if you notice that they say PyCharm is an integrated development environment used for programming in Python. But there are some programming design tools that you use when you're doing programming, writing in the programming language. It doesn't have to be Python. This one is only generic to only Python. But you have other programming design tools that once you use those programming design tools, you can write any program at all. It doesn't matter which programming language you're using. Once you use those basically four programming design tools, then you can go ahead and write any program at all. Let's say, for instance, you are proficient in writing programming in Python, and I am proficient in writing programming C#. And Finas is proficient in writing program in Visual C or in C++ or F#. Once you use any of the programming design tools, the 4 programming design tools, then let's say for instance we are working at a place and we are given those one or more of those programming design tools, then you can write using your language that you are proficient in, or using write a language that you are proficient in. So the programming design tools that I'm looking for are like flowchart, algorithm, pseudocode, trace
Yes,
table,
sir.
and IPO table. Those are the programming design tools that no matter what programming language you are using, right? So if you if you limit yourself to PyCharm and you get a job, for instance, and they gave you a flowchart or an IPO chart or a trace table or an algorithm or a pseudocode, then you should be able to interpret those programming design tools to write your program in Python. Right? Let's say the company doesn't have PyCharm, but they have a team of programmers, and different programmers might write in different languages, right? And they give you the flowchart or the algorithm or the pseudocode or the IP or trace table. Then you should be able to take that flowchart or any one of those design tools and write a program. Everybody follow? Hello?
Yes, sir. We
Yes,
following.
sir. I understand, sir.
Yeah. All right. So we're gonna look again and at some of these simple programming design tools that is universal. It is universal. It doesn't matter what language you're writing, but these are universal, right? We look at it already last week. I don't know how far we had reached. Did we cover the one entire thing, or did we just cover just a part of it? I don't think
We
we did
can,
reach
we
right
can,
here.
yeah, or you can start it all over because I don't, Odin, I don't know whether he was around when we did the last
Okay.
one.
All right.
Yeah.
I think I watched this video a good while ago, sir.
Yeah, I watched this video a good while ago.
Yeah, but I don't
Okay.
remember most of the stuff that he said, but I think I watched this video a good while ago.
Okay, so it doesn't hurt if we say we can go it over again and so we can speed
Yes,
it up
sir, no
this time.
problem.
All
Yes,
right.
sir.
So
Yes, sir.
before you write in a programming language, we usually have what is known as an algorithm. Then you can
Yes,
convert
sir.
the algorithm into flowchart, then the flowchart into pseudocode, and into a trace table or IPO table. All right. So let me just see if I can start it from here. All right.
Of step-by-step instruction. Good afternoon, ladies and gentlemen. My name is Wong Mu Lin. I'm from the Computer Science Department, and today I would like to introduce to you the concepts of algorithm, flowchart, and then we convert them into C programs. First, we're going to start is, what is algorithm? It is a step-by-step instruction to solve a problem. And whatever problems that we have, we can be able to solve it step by step. And over here, you'll be able to see flowchart. Now, flowchart is a pictorial representation of step-by-step instructions to solve a problem. So before we go into flowchart, here are some of the basic symbols that I'd like to introduce to you that you can use as a reference. The oval shape over here is start or stop, whereby this parallelogram indicates input and output. This diamond box over here is used for decision making, while this rectangular box is for process. Now, there's this rectangle box as well, with added symbols. Right? That's a predefined process. This symbol represents looping, and this circle represents a connector, and while the arrow in the last, represents flow direction. Now, all these things over here will be used in our explanation. So first, we need to have a problem. So from this problem, we will be able to see how we can use algorithm and flowchart, okay, to be able to solve a problem. Now, let's say we have the first problem. We need to find the average of 3 integers. This is a very simple problem. How do we use algorithm to solve it? Well, we start with step 1, start. Then, step 2, we have to output. We need to let the users know what programs we are doing. So therefore, we need to give some instructions. So first of all, we need to mention that this is a program, all right, to find the average of 3 integers. And of course, we also need to give the next instruction, that is to input 3 integers. After that, we need to give a command so that we can be able to input 3 integers. So assuming we have a variable for each integer, starting with A, B, and then C. So afterwards, in step 5, we can be able to calculate the average. All right? So average is the sum of A, B, and C, and the total of it divided by 3. This is how you get the average. And then in step 6, we can be able to display or output, all right, average is AVE, which is the variable that we use to calculate this simple mathematical problem. And lastly, in step 7, that's where we stop. So this simple problem over here is...
All right, so usually when you get something like this in the exam, they might just give you something like this in the exam and say, write an algorithm for calculating the average of 3 numbers, 3 integers, or they might just say, write an algorithm to find the profit of a sales. Or they might ask you to write an algorithm to divide 3 numbers, and they might just give you a formula. For example, the fundamental of electronics, a formula for fundamental of electronics, V is equal to I multiplied by R. They might just give you the equation and say, write a program, a small program, or sorry, write an algorithm to calculate the voltage given the current and the resistor. Or write an algorithm for a voltage in terms of resistors and current. And this is the step that you're going to take. The first step, you're going to write the word start. And the second step, what will you write for the second step?
Sir, we must just write start, or we must draw the shape with it also.
Write start. You're gonna write start. So let me just go back a little bit. So you're gonna start it out like this. So you write the word start.
Yes, sir.
Right? And then after you write the word start, you're gonna say output. And so this output that you see right here, this output is telling it's like you're reminding yourself that you're supposed to output something on the screen. You want to put something on the screen. So it's like you're directing the user. So this one is directing the user, and this one is really what you will do.
Yes,
right?
sir.
So
Yes, sir.
you as a user will see this. So if you're writing the code in Python, then you put print print average of three integers because that's what you want the user to see. So for if you are doing the voltage in terms of current and resistor, you say output find the voltage or voltage of a circuit given resistor and current. Right? So that's what you'll put for the output. That's what you want the user to see. Right? You are giving them direction. Then another output would be now input two numbers, don't it? Because if you are to find voltage in terms of current and resistor, they won't give you the three numbers. They'll give you two numbers to find one. They'll give you the current, or they'll ask you to supply the current, the value of the current and the value of the resistance to find the value of the voltage. So right here, you would put input two values, or input current and resistors. All right. And down here now, input ABC. You wouldn't have ABC, but you also input A, B. Right? And down here, you would put now, you'd actually put the equation voltage. So right here, you'll have voltage with an arrow, and then you would put the equation for voltage. And voltage is equal to current multiplied by resistor. So you won't have this equation, but you will have I multiplied by R. Right? You would have V with the arrow and I multiplied by R. Right? But this one they are doing the average. So they'll try to find the average for three numbers. So A, B, C are variables. So they use these three variables and they divide by 3 to get the average. Out here now, the output stage, this is what you would print out now. Output, and I say voltage is, and I put the value and the value of the voltage. So voltage is, and I put voltage right here, or volt. All right, and then step now, you just say you just print stop. All right. So you would have it like this. So it's clear now. All right. So this is what I want you to do now. I want you to write an algorithm, just like I print it. I want you to write an algorithm to find the voltage of a circuit given the resistor and the current. Write it out and share it to me and let me see it stay. Write an algorithm to find the voltage of a circuit in terms of resistor and current. You understand that?
We're gonna write it on.
Yes, write it on a piece of
sheet.
paper. Yeah, write it on a sheet of paper and then share it with me. I'm waiting. All right? Because I want to make sure that when I go into the exam, and if they ask a simple question like this, you're supposed to can handle it. So go ahead, do the activity. I'm giving you 1, 2, 3, 4, 5, 6. I've almost steps out here. 1, 2, 3, 4, 5, 6, 7 steps. So I'm giving you about 3 minutes, half a minute to write one part, or less than half a minute. So I'm giving you about a minute, so about 2 minutes to write this.
Okay, but sorry the question. Sorry, so that I will know what we're writing.
All right. Sorry. So I'm gonna tell you the question again now. So you're gonna write down the question. All right. Find the write an algorithm for voltage given current and resistor. Write an algorithm to find the voltage of a circuit. You have that? Write an algorithm to find the voltage of a circuit given resistor and current, or current and resistor. You all finished? Anybody ready to share?
So can we do this one together? Then maybe you change the question again.
You have that? So you write the word start as a step 1, colon, start. So you can put step 1, colon, start. Then step 2, colon, output, open quotation, voltage of a circuit in terms of current and resistance, close quotation. You have that?
Voltage of a cycle.
Voltage of a circuit in terms of current and resistance.
So if it's given in the exam, are we gonna type it like that?
Yes, you're gonna type it like this, just like this. You're gonna say step 1, colon, start. Step 2, colon, output, open quotation, voltage of a circuit in terms of current and resistance, close quotation.
So I have a question. Some
Yeah.
calculation during exams, how are we supposed to solve them and submit them? And I don't think we are using APA formats when submitting the exams.
Yes, you'll be using APA format throughout the whole entire thing.
The exam, because
yeah.
Miss Allen told us that she don't see reasons why we should use APA formats in submitting exams, because they mostly just need the answers and reference and other
No,
things are not important. It's just on the coursework.
I understand, but on the safe side, do
yes,
APA format
do
in
APA format
everything.
in everything. Is a college, you're doing college work, and if you get a case study to do, then you use the APA format. Use the APA format for everything that you get to do.
Oh, okay. That means there will be
Right?
reference during the
Yes,
exams.
yeah, reference the Times New Roman, double space, and all those things.
Oh,
Okay.
pardon the noise here. I'm on site. So
Yes,
pardon
yes.
the noise, please.
Yeah, man. All right, so ready for step 3 now? Step 3, colon.
So you didn't answer the last question, sorry, the one of
What
the
was it?
calculation. The one for calculation I asked.
Oh, yeah, what you're asking again about the calculation, no?
I said if
Okay.
there are calculation, how are we gonna submit it? Are we doing it on a piece of paper
All right.
and
All right. Usually, if you do it on a piece of paper. No, it's best to type it, because usually they give you some time, especially if you're doing it online.
yeah.
They might give you some time, like about a day or so, or less than a day, like about half a day. Or sometimes they give you a day. And the last time I know, during the COVID thing, when they do it section 2, section B, they usually give you like a day or something like that. And they usually is a case, usually it's case studies, and they don't really have a lot of calculation for section 2. But they have like case studies where you have to solve a problem or something like that. Yeah?
And this is a 60-40, sir, right?
Yeah, 60-40. You can go into the exam, passing the exam already, because the coursework take more than the exam. So the coursework is 60% and the exam is 40%.
Yeah, especially the lab them where you give it hard.
Right. Yes. That is why you need to maximize. You need to maximize on them, because person can't fail the coursework. If you fail the coursework, it's like you fail the exam. So once you get the coursework is like you actually start your exam. Any college or university you go. Any college or university, once you get the coursework, they'll start working it fast. Because this time we just catch up on you just like that.
But sir, a whole heap, sir.
No,
And
it's not
most
a
of
whole lot.
whole heap. You're
Yeah,
one long.
but
But
I gave you a
understand that,
long time. So what I want you to do, you see, I don't want the coursework to go over into January. I want everybody to finish the coursework before the Christmas holiday, before Christmas. I
Okay.
submit it. All right. So I'm not gonna
Okay.
put in the time limit on it, but make certain that you finish it before Christmas. I don't want it
Yes,
to
sir.
go.
The
I don't
labs.
want it to go into, yeah. So I don't want it to go into January. No, not all.
So
All right.
after you think a CAD for the labs, then, sir.
Um. Yes. Use think I can. I wouldn't mind if you did come in to do some work on the actual boards them, but at this point, just use Tinkercad.
All right, no problem.
All right. Yeah. Just use Tinkercad. Mm-hmm.
With this programming, sir, why them just don't get straight to the point like what you are doing? This is what you do not get straight to the point. Said this is for that and this for that. I was learning it from a different institution, and they must go around. They must go around. I not understand nothing.
All right.
You see, you just understand now.
Oh, about the 60-40 thing. And about
No, sir, about the steps.
the steps.
About the steps. Yes, sir.
You mean with the algorithm?
Yeah.
Yes, sir.
Yeah, because a lot of processes is not everybody can teach programming and teach it the way. Oh, you understand? Just some persons can teach certain thing, and some persons don't understand how to teach it. You have a lot of IT persons who they are afraid of programming. You know, even though sometimes them have their degree or their masters in it, they're afraid of it. They are not really proficient in it, so they stay away from it. All right. So step 3 now. You finish step 1 and step 2.
Yeah.
All right. Step 3 now. Write the word step 3 colon, and you're gonna output this now. You're gonna say something else to the user now. You're gonna ask the user to do something now. The first one, you're directing the user, this output, you're directing the user, telling the user what is going on, what they're supposed to do. And with step 3 now, this output is asking the user to do something now. All right. So you're directing the user again, but you're telling them what to do. All right. So you write the word step 3 colon output, put in quotation, input input resistance, input value of resistance, and value of current. Input value of resistance and value of current. Sometimes they make you do it 2 times, one up here and one down here, but just do it right here. Input value of resistance and value of current. And then close the quotation. Yeah, so open quotation, input value of current and value of resistance, then close it. And because it's only two values you're putting in. For step 4, you're gonna write step 4 colon input I comma R. Remember what I is? I is what again? I is current, don't it?
Oh.
And
Yes, sir.
R is resistance.
Resistance, yes, sir.
Right. So you say step 4 colon input I comma R. Step 5 now, colon, what you want to find, voltage, don't it? So
Yeah.
so you say volt,
Yes,
put
sir.
a arrow right here. I'm gonna write the equation to find voltage. What's the equation to find voltage in terms of current and resistance?
V
V is equal to what?
V1
V is equal to I times R, don't it? So out here you're gonna put
yes, V
right. So out here you're gonna put voltage or volt. Put the arrow right here, and then right here now you're gonna write the equation I times R. I multiply by R. Thus I put the multiplication sign and then R, and that's it.
is
So in
gonna
the
be
programming,
times, not
No,
plus.
times. No, time. No, not plus. This right here so is to find the average of 3 numbers. But what you
Oh,
are doing, you are finding the voltage of a circuit in terms of current and resistor. And to find voltage, the equation is I times R. So right here, you would put I times R. It's as simple as that. I times R.
okay.
Right? For step 6, you put colon. And I'm gonna really print out the voltage now to show you what the voltage is. So you write the word output, open quotation, voltage is, I close the quotation, put a comma, and put voltage or volt. So you say output, open quotation, voltage is, close the quotation, comma, volt. Right here again, you'd have the volt because the volt would equal, V is equal to I times R. So you can write V if you want, but write volt. Volt is equal to volt, come with the arrow, I times R, and down here, volt, open quotation, voltage is, close quotation, comma, volt. So voltage is volt. All right. Anybody have any idea what's the difference between voltage and volt? Why I use voltage at some time and I use voltage at some time?
no, sir.
I actually thought it's the same thing.
No, not the same thing. All right. So voltage is anything that causes current to move. The unit of measurement of voltage is the volt.
Oh,
You
That sound
understand
like
now?
physics.
Yeah, man, it's physics. Yeah, it's physics. All right. And then now, step 7 now, put colon, and then write the word stop. And this is known as a sequential program. So I'm gonna let you practice one on your own now. So the one that you're gonna practice on your own now is to find the power of a circuit. Can you do that? Can you find the power? Can you find the power of a circuit? What are some equations that you can use to find power? What are 3 equations that you can use to find power? Power is equal to what? All right. You want to write another one now? But I'm gonna let you write one for profit. The profit of a sale price and a cost price. Can you write one for that? I'm gonna come out of the electronics now and let you write something general. The profit of a sale price. All right. So let me get the equation for a profit.
I guess power is equals to watts. It goes in watts. I don't know.
The power. No. I'm not gonna give you
because the units of power is watt.
Yeah, the unit of power is watt. But you can find power 3 different ways. But I'm gonna ask you to do to go into some accounts now, because remember that you're writing program, and you might not get anything to write program for electronics alone. You might get something to do, some simple accounts like profit, right? Somebody selling something and they want to make a profit, and profit is equal to sale price minus the cost price. Right? So you can write down the equation for profit. Profit is equal to sale price minus cost price. Write down that first. And that's what you're gonna put for step 5. Profit is equal to sale or S minus C. P is equal to S. I can say profit is equal to S minus C. Write down that first. You're gonna use that for step 5.
S minus C.
Yeah. S, and S is the sale price and C is the cost price. So what I wanted to do now is to write an algorithm. This is the problem that I'm giving you. So you're gonna write the problem first. Write an algorithm to find the profit for a sale price and cost price. Write an algorithm for profit to find the sale. Write an algorithm to find the profit of sale and cost. All right, so go ahead now, write it and then show me it. Then we're gonna start off with start. You're gonna write the output same way. What would you put for step 2? What would you put for step 2? Talk to me. What would you put for step 2?
Step 2 will be output. Output will be
Right. And what would you say in it? What can you say? Profit of sale and cost.
Yeah, profit of
Profit of sale price and cost price. All right, for step 3, what would you put for step 3?
I'm coming.
Step 3.
Yeah.
Input, right, sir?
Yeah, input, right? And how many things would you put in? What did you do? One? Say it. You say output, open quotation, input, And what we do? What you want to put to get the profit? What do you want to put in?
Profit with
no man. No, for step 3, you write the word output in quotation, then you say input, and what comes after input? What go on, say it, yeah man, yeah man, you're on the right track, say it.
Sale price.
Yes. And
cost price.
Right. And we close the quotation. All right. Then step 4 now, what will you put for step 4?
Cost price. Sorry, I'm writing to, sorry. Step 4 will be, let me see,
input. You write the word input. And what you do now?
It's going to be, let me see.
2 letters, only 2 letters you need.
SC.
Input, right, S, comma, C. All right, and step 5 now, you'd actually put the profit. You write the word profit.
Profit is equal. Yes, profit is equal to S minus C.
Right. And what would you put for step 6?
I'm coming. Let me write the one for step 5. S minus C. Then okay, step 6 is going to be output. Output, then it's going to be it's going profit. Let me see, profit equals to.
Right? I just heard it well. I just heard it well.
Profit. Yeah. Profit equal to
I just say profit is
okay.
P,
profit is
P. Our profit. Profit is profit. Our profit is P. Our profit is prof. I don't have to really write out the real entire word profit. You can say profit is prof. All right. Okay. So now that you understand that, we can see if we can go on to write the flow chart for this now. Then you are going to see if we can draw a flow chart for the 2 of them that you did before. All right. So you're gonna look at this flow chart and then write an example flow, draw an example flow chart for these 2. All right.
In a flow chart, how do we draw it? So it will be quite similar to what we have over here in the algorithm. So let's look at this. Now to start, we need to use an oval shape. Okay, so the arrow indicates what's the next step. The next step is for us to do output average of 3 integers. So we can show over here average of 3 integers.
And remember now, when you're writing the word start, it's going to oval box like this. Not a circle, but oval. Right? And when you're doing input and output, the input and the output go into a parallelogram like this one.
Now we also need to output another statement, so I can put them in the same box. So after this is done, the next step in step 4 is that.
No, sorry, I was not hearing, but I started hearing what he's saying.
Okay, you see now, so the parallelogram is used for input and output, right? So this particular shape is used for input and output. Now this one right here is output average of 3 integers, so they put it right here. And output again, input 3 integers, so you put 3 integers right here. right? And then because these are instructions that you are giving the user. You are displaying something out here. You are displaying something. So you put it in a parallelogram. But even when you are inputting something too, like this input down here, you're gonna use a parallelogram again. So the parallelogram is used for both input and output, right? So they put two of these in here because these are displaying something that they are directing the user. So they put both of them together in one parallelogram right here. Let's say for instance they go to an ATM machine and they see the screen showing something. When they are doing this, when they are designing the program, they design it like this, and they might have a little display, like a little advertisement going on the screen, like some animation or some movement going on. When they design the program, they put all of this in it, like they say animation, advertisement, output advertisement, right? And then and then when you put in your pin, the card now, it might just display something again. So they'll put the design in a box like this again, right?
That we need to input the three numbers. So the shape is still the same, parallelogram, input, A, B, C. Now, by now, I think you'll be able to have an idea that in algorithm, it is line by line of simple instructions that we can be able to accomplish.
All right. So right here now, the computer is supposed to act on the information, don't it? The computer is supposed to process or act on the information. So once the computer acts on the information, it is a processing taking place right here. So what you do now, you'll put for the flow chart right here, you'll put a rectangle. A rectangle box is for processing. So the computer will be processing this information right here. It will be processing the data. So right now, you ask the person right here to put in three pieces of data, right? And then the computer will now process those three pieces of data. So it's gonna be a rectangle box. All right.
Whereby in flowchart, we use a diagram. All right. After this, we need to do a process whereby we can be able to find the average. So average is actually the sum of A, B, and C, and the whole thing divided by 3.
Right.
And after
and this is where the computer would now be running the process to process all of those information.
The average. So right? Average is
so
actually
the computer
the
get
sum
the data.
Of A, B, and C, and the whole thing divided by 3.
Right. So the computer will be.
Now listen.
No, sorry about that. Sorry about that. Man catch the thing. Man catch the thing right here.
Now we also need to be able to have this
Right. So this is what the computer will be processing. Right. So the equation that you put in, the computer will be processing this equation. Right. And that's the power of a computer. No matter how complex an equation can get, because an equation can get very, very, very complex. So this is where you put it. So instead of you spend your time doing all of this in your head, you put this in the computer, and that's the purpose of a computer, to process this information and to spit it out very, very, very fast. Because let's say for instance, you'll be finding the average of 100 numbers. It should be A plus B plus C plus D plus the right hand, don't it? Don't
yes,
it, people?
Sir.
Right. So if you are to find the average of those numbers and you are working it out, it will take a long time, don't it? Suppose
Yes,
you
sir.
have
Yes,
100,
sir.
right? So once you put the equation in the computer, right, and you run it, then the computer will just split out fast. So this is where the processing, so the processing is done right here. So they use a rectangular box to denote where the processing take place. All right. And when it processed, it is outputting something now. So use a rectangle. So use a parallelogram again now to show that it is outputting something.
Is AVE. And with that,
and then stop it right there. All right. So what I want you to do is two things. You're gonna write a flow. You're gonna draw a flow chart for the one for the resistance, and you're gonna draw a flow chart for the one for the profit. So go ahead right now and do those two flow charts. Let me just come back a little bit with it so that I can see it a little bit better. All right. All right. So you can make that out now. So up here is start, and this is where you're directing the user. This is where you ask the user to input something. Then the processing take place right here, and then it output again, and it stop. Right? And this type of flowchart or this type of algorithm is known as a sequential algorithm or a sequential structure. Right? Because everything is in sequence, one line at a time. After the start, then you would display something directing the user. Then you ask the user to put something in, put in some piece of data, and then the computer process it. And after it process or execute it, then it give you an output and then stop. All right. So just write the flow, draw the flow chart for this one now. Draw the flow chart for the one for the voltage and the flow chart for the one for the profit. So draw those two flow chart and then display them to me and show them. So you must can do that now, don't it? Hmm? Hello.
Yes, sir.
All right. So you're gonna write draw those two flow charts for me. One for the voltage and one for the profit.
So we should do them now?
Yeah. No. I don't want to see how well it's right so that I can once you start to do these, and then I'll give you something to do, like a coursework on it, then you know exactly what to do.
Sorry, I didn't get what you said, sir. Sorry.
I say once you get this to do, once you understand programming design tools, then I'll just give you an assignment to do, and then you'll complete it and then I'll give it back to me.
Okay.
Probably sometime in January. Now early January.
To do any
Or then you understand what to do?
Yes, sir. I do understand, sir.
Okay. Phineas, you still? Are you understanding, Phineas?
Yeah, I'm picking up.
Okay. So how you guys stay now? You guys finish? You guys finish everything? Hello?
Yes,
You want to share?
Odin, are you starting? I'm coming.
Okay.
I don't know if
So Odin, you want to share? All right, Phineas, share. You share, Phineas. Let me give you a share privilege. Hold on. All right, you can go ahead and share what you have now.
I'm coming. I'm coming.
Nobody not share, nobody not telling me where them have. All right. Should we move on? Hello. So I'm going to move on.
Sorry, sir. I actually had. I'm trying to check if it's correct because I'm not sure of it. That's why.
No, still show what
Yeah.
you have,
But
yeah, still show what you have so we can help you correct it. All right, so go ahead and show it.
okay. So we start. All of them are from step 1 to 7, I guess.
Yeah, yes, because it's a simple program. I never make it too complex. A simple program.
Yeah, step 1 is going to start with. We all start with starts. That's for step 1.
All right, so show it on the screen. You know to show it on the
I'm
screen.
using my phone.
Using the phone.
I'm using my yes.
All right, so you still can show on the phone, man. You still can show it on the phone.
Oh, okay. Coming.
All right. So oh, you're showing it? Um, the flow chart. Let me see the flow chart. How the flow chart look? All right. Yeah. So that's the algorithm. The algorithm look okay. But let me see the flow chart now. Yeah, yes, Phineas. As I'm seeing the algorithm. I see the algorithm. So let me see the flow chart now.
Can you hear me, sir? I was stuck
Yes.
in my mic. My mic was off. Sorry.
Okay. Yes. So
I
I
said
was asking
for
us
the
to show the flow. What to do?
flow.
Take a picture of it. I'll show it in the WhatsApp. Let me see.
Okay.
Show it in the WhatsApp. Let me see. Let me see it there. So Phineas, you sent it already. All right, let me check it.
Sir, I'm coming. I'm coming.
You don't send it yet.
I'm trying to do it now, sir. Like that's why it's taking long.
Oh. All right, make sure we can go on in the meantime. All right.
Okay.
So we're gonna look at another problem now. He's going to attempt to write this in C, but we're not doing C. We're doing Python. So I'm gonna this right now. This is a C program. So it's actually transferring it now to the coding. That's the information. He's transferring it to coding. So we're gonna do some pass this and go to another.
C plus.
Yeah, no, not C plus, but C.
Oh, I
So
thought I thought there's a program for C and C plus.
yeah, man, you have one for C, you have C plus plus, you have C sharp.
Oh,
So the one that we'll be doing next semester is C#.
Oh,
So we're gonna look at another, and this is what they will write their own in C program and Turbo C++. So C and C++ Turbo C++ can do it like this. So let me look at another problem now. I'm gonna look at another problem, and this first problem that we'll look at is a sequential problem. So this is now problem number 2. So this one that we do look while is known as a sequential program. Hold on, before I get to before this. All right, so notice that everything is straightforward, sequential, one after the other, after the other, after the other. Algorithm is the same thing, flowchart is the same thing, and the coding is the same thing. All right, but they are sequential, one line after the other. Right, now we're gonna look at some other ones now that are not really sequential, branching. All right, this is Odin is saying hello to everyone.
Yeah, that he can. Yeah, that's what he's saying. I guess is his internet maybe.
Oh, okay. All right. So let us look at problem number 2. All right. Step 1, start.
So are you sharing the screen? Because I'm not seeing it.
It was sharing.
Yes,
Sorry
sir.
about that. Let me just share.
Mm.
All right, here it goes now. Seeing it now?
To do this to solve the first problem. Now, next, I would like to show 2 more examples, 2 more problems, so that you can be able to have a better idea. Find the largest of 2 integers. So let's go through this. Step 1, always start. Step 2, always let the users know what this program is. Maybe we can write largest of 2 integers. Step 3, we need to instruct the user input 2 integers. Step 4, we need to receive these 2 integers, so input A, B. We can use any other variable names. Over here, I just want to use A, B. Next, we need to compare. If A is bigger than, since we're looking for a larger number between A and B,
So we're not hearing anything.
Oh, sorry. So right here, this if right here, this if is called a conditional line, right? And usually when you are using conditional, or when we are writing any condition in programming, we usually use an inequality like greater than or less than, greater than or equal to, less than or equal to, right? And sometimes they put a little equal sign. So, but most of the time, especially when they want it to loop, they use a greater than or equal sign, or a greater than and a less than. All right. So and also when you're doing the flow chart, there is a diamond right here. The diamond shape, the shape that I use for if or conditions is a diamond. So if they ask you in the exam, what flowchart symbol they use for the if condition, it's a diamond shape. If they ask you the other way, on the diamond shape on the flowchart, usually denotes what? A condition or a if statement. All right.
So if A is bigger than B, then immediately we can be able to have an output largest is A. This is step 6. Then we have step 7, else. Step 8, we can output largest is B.
All right, let me stop right here now. So right here, right after the condition, you're going to have two output. You're going to have one of two output. So right now it is selecting. So this structure now that they are writing now is a selection structure. The first structure was a sequential structure. This structure now is a selection structure. So we have three different structure when you're doing programming: sequential, selection, and iterative or looping. So in this case now, they are doing what is known as a selection. Either they're gonna select A or they're gonna select B, right? So when you draw a flow chart and you have that diamond shape gonna have two output or two branches, right? One branch is saying output is larger, output largest is A, else output largest is B. So you can either choose A or it will choose B, right? So it will select A or it will select B. So they call it a selection statement, right? A selection structure.
And then we finish, so we stop.
Okay.
Now if we look at the algorithm, we can be able to draw the flow chart. Or vice versa, we can look at the flow chart, we can be able to write the algorithm.
Right? So if I give you a flow chart, you're supposed to can write the algorithm. If I give you an algorithm, you're supposed to can write the flow chart.
So the program is largest of two integers.
So right now what you're doing right here now, you're telling the user what the program is about.
Then we have the instruction to input two integers.
And now you're instructing the user now what they're supposed to do.
After that, we need to input A, B. Now, because it is a decision, right? So we use a decision box.
So this is how the if come in now. If, right? So as long as you see in the program that you're writing and you have a if, use a diamond for the if. Right? Always use a diamond. Anywhere tell us the if is a diamond. It's diamond shape right here.
Diamond box. And we ask this question, A, is it bigger than B? Right? We put a question mark inside the decision box.
And you answer a question sign instead of a decision box. All the while.
Right? So we use a decision box, a diamond box. And we ask this question, A, is it bigger than B?
All right. So let's say if A is bigger than B, you're gonna branch this way, or you're gonna branch this way. Is A bigger than B? You can go this direction or you can go this direction. Right? You can say if A bigger than B, yes or no. If it is yes, you go this direction or that direction, depends on how they want to draw it. Or if B is greater than A, then you go this direction. But you usually have branch off, and then make a selection for the A and a selection for the B. Or sometimes you might draw a different box and say A less than B. Is A less than B? So you're gonna have, if A is greater than B, you go that. So they ask it like this. Is A greater than B? Yes or no? Is A less than B? Yes or no? Right? And they go on like that.
Right? We put a question mark inside the decision box.
Okay.
And in a decision box, we always have two outcomes. Right? Either yes or no. Either it is true or it's false. So imagine, okay?
All right. So in this case now, suppose A was greater than B. Which direction would it take? The yes or the no? If A was
It's
greater than
gonna
B,
take
if
maybe yes.
all right. Suppose A was 2 and B was 1. Which direction would it take? These are exam questions, you know. If A was 3 and B was
Okay.
1, A is 3, B is 1. Is 3 greater
It's
than
still A. It's still
is
A.
all right? Is 3 greater than 1? Yes. So to take this
Yes, sir.
direction. All right. All right.
Yes,
Another
sir.
question. Suppose A was 2 and B was 100. Which direction it would take? This is 2
B.
and this is right. So which direction would it go? Yes or no?
No.
No, it will go this way.
Let's say we put yes on the left-hand side. So we are going to output largest is A. If A is bigger than B, if it's true, if it's yes, then the largest must be A. If not, we have to output largest is B. Now after we finish, either the answer is yes or no. After you finish the output, you should come to the end, which is to stop. When you use this flowchart as
All right, so this is what is known as a selection structure. The first one
B.
was a sequential because it was straightforward, but this one
Now
now,
after we finish, either the answer is yes or no. After you finish the output, you should come to the end,
right, and that's a
which
stop.
is to stop.
All right, so now this is known as a sequential structure. No, not sequential, but a selection structure, because it make a selection right here, right? Either I select A and output A, or I select B and output the B. All right, so you select one of two. So this again, this is a selection structure. The first one that we did was a sequential, okay? It was straightforward. All right.
When you use this flowchart, especially when you have complicated programs, it helps us to understand the program better. Of course, now we're using a very small problem, so the programming seems to be very short. So therefore, you see that there's not much difference between an algorithm and a flowchart. But in reality, when you have bigger programs, you would be able to understand using a flowchart much better. All right. So let's see how do we do it in a C program. So I maintain the same header files, so we don't need to change that.
So let me just change
Let's
let me
do
just
that. I'm
further
going
on.
to in one line.
So we're gonna do next one now. They're still writing this in the C program. So we're gonna do another one now, which is the iterative or looping.
We need to
So this is
find the average. I let the user decide how many numbers he or she wants to insert, and then the program is still able to calculate the average of those numbers that he inputs.
sorry.
Step 3, let's start. And especially larger programs, we will not have a lot. Third problem. In this third problem, I want to introduce the concept of looping. This time, I want to find average of n number of integers. So that means, instead of fixing it, I want 3 numbers, and then find the average. I let the user decide how many numbers he or she wants to insert, and then the program is still able to calculate the average of those numbers that he input. So let's start. Step 1. Always start. Step 2. Okay, output as usual. Average of n number of integers. Step 3.
And any is a variable, and the variable can take on any amount of numbers.
output. So we have to ask a crucial question. How many numbers do you want to insert? How many integers? Step 4, we input n. Okay, so n refers to how many numbers.
Alright, what is n? In this case, what is n? No, what value is n? Does n have any value? Does n
Yeah.
what is the value of n?
Okay.
It doesn't have any value. It can be any value at all. It can be 1, 2, 5, 10, 16, 20, 100, 1,000. You understand? It can be any at all.
Okay, so n doesn't have any value.
Doesn't have any value. Right? So say you want the person to find the average of any number at all you put in. Suppose you write a program and I say, right, I want to find the average of 3 numbers. Then you can put in 3 numbers in here, right? And they say input n, but n can't take anything at all. Suppose you want to put 3, you put the 3 right here. Suppose you say you want to find the average of 10 numbers, then n would be 10. Suppose you say you want to find the average of 30 numbers, then n would be 30. You understand? It doesn't have any value.
That we need to have. Okay, after this is done, we need to tell the user to start inserting the numbers. So step 5 over here, we output, and we say insert n, okay, integers.
Good. I could say insert 10 integer, insert 2 integer, insert 40 integer, insert 3 integer, insert 100 integer, insert 1,000 integer.
So step 6, right, this will be a bit long. All right, so after we tell it you can insert n number of integers, then what we do over here is that we use looping. We can use different ways of looping. So I'm going to use for loop. All right.
Right. So we have a lot of keywords that we can use to do looping. Let me just look at some of them and show you now. Look at this some of them very, very fast. So we can find some of them very fast. Right, so wait. This one right here is a for loop, right? You can ask the program to loop. When I say loop, let's say for instance you go to the ATM machine and you put in your PIN number, but you don't remember it and you put in something wrong. It asks you again to put it in, right? In this case, it will ask you to put it in 3 times. And as long as the set of value for I, for example, and they say I is equal to 1, and I is less than or equal to 10 plus I. So what it's gonna do, the program, the statement above, it will read this line, and this line will say if the if statement again. So if I is equal to 3, continue. If I is equal to 7, break. Right? So you want to go as far as to about 10, but you want to break it at when it reaches to 7. So I would attempt to continue until it reaches 10. If we don't go to your ATM machine and you put in a pin one time, you put in a pin wrong one time, it loop. Or it asks you again. If you put it in again, it asks you again. So it asks you about, so they set loop for about three, right? And once you put it in wrong 3 times, then it will tell you that you can't draw the money until about 1 hour or 24 hours time. Right? So the looping thing is a fail safe thing as well. Same thing with the phone. You put in a password in the phone 3 times, I put it in wrong, the phone will lock you out. I have to tell you that because is a security mechanism to try to save something, to save some document, right? So if you are trying to put in something 3 to 4 times, then it will lock you out, right? So this is the purpose of looping. So you can use the for loop. Yeah, hold on, just a minute, Hello? Yeah? Yes, Mark. Yes, but I remember no, I don't usually have you guys until about 1 o'clock. You can't get to her. Oh, all right. Yeah, man. Class. Yeah, man. Okay, all right. Yeah, man. Class keeping. Yeah. So just come and when I finish with this class, then I'll just do with you guys. All right. Yeah, man. Yeah. Mhm. All right. So you have loop and tail as well, and you also have do while loop. So let me show you another type of looping that you can use. Looping structure. Hold on. Double tree school looping. Alright, for loop. So this is a for loop looping. So this is how you do a for loop right here. Right. Your for loop. For Python. Looping. Hold on. I put looping in Python. Hold on. Python. All right. So looping. This is not it. There it is. Does it require? Oh, you're right. See it right here. So you have a while loop and you have a for loop. Let me look at the for loop first in Python. So if you are actually writing the code, right? So you'd write this for Python. So let me just try this and you see it run. All right. So this is, so you say fruits, apple, banana, cherry for X in fruits. So it print out all of this in one go. All right. So let me just run it. So it print out this in one go. All right. Let me just go back again. All right. Get a different one. All right. Try this one. That's cheating. And it is just looping for banana and cherry. Right? Not looping for apple. For X in fruits, if X equal banana, continue, print X. Right? So this is fruits. Let's see if I can send another one. Right. For X in range 6, print X. All right, so it loop until it reach down to 6. Because this is really 6. 1, 2, 3, 4, 5, 6. So the count 0 as one of them. Right. So let us go back to this now before it get too late. All right, now, so where was I now before? Right. So we're gonna continue the looping.
Right. So for I starts with, let's say, 1, 2, and do. So what do you do over here? Step 7. We input A. Then step 8. All right. What we do over here is that we have to make sum equals to sum plus A. All right. And then step 9. So after we have done this, every time that you get a number, you add it to the sum so that we can be able to get the overall. So after you have finished doing this, how do we know that we have finished doing this? So there are ways we can do this. For one example is that we can be able to use indentation and make these 2 statements being indented inside so that you can be able to know that, okay, these 2 statements belongs to this for loop. Or another way that we can do this is that we put a remark over here, end of for loop, step 6. All right, so this would tell us as what you call it, viewers, we can be able to see, okay, that's the end of the loop. Then step 9.
Because you can have what is known as endless loop. You can have something that is looping, 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 and will never stop.
Over here, we want to find the average. So AVE is assigned to sum divided by n. All right? Okay, so then we can solve it this way. Finally, step 10. Step 10, we have over here output. Average is AVE. Step 11, we stop. All right? Before we go into this flow chart, I would like you to take note. Do you happen to see of any error over here? If not, never mind. We go into the
flow chart very, very fast. So we're gonna have to look at this again next week because we're gonna have to stop here shortly.
The n value.
To give you a break and let you come back for the next class.
That refers to how many, all right, integers that we want. After that, we output insert n integers. I starts with 1 to n do. So what do you do inside? Well, first of all, you need to input A. So we have input A. After that, you have a process whereby sum is assigned with sum plus A. And after that finish, that's the end of the for loop. So that means that you're going to go up again. So depending on the n value, you are going to loop n number of times. I starts with 1, all right, and then you keep on looping. So therefore, I is supposed to increase, or the value of I is supposed to increase. We put over here I.
So they call it iterative. When it increases, they call it iterative.
Plus plus. Or else, you can also put it this way. I is equal to I plus 1. All right? So over here, you use the dotted line, and then come up.
And suppose the I, the initial I right here. I'm not going back to the I. Suppose this initial I for I is equal to I plus n. Do input A, right? So suppose this I was equal to 5. We have 5 down here. So when the program reach down here, 5 would be equal to 5 plus 1. I suppose, all right, like, no, this is 1, not 5, but this is 1. It is 1, right? But say, suppose you say I is equal to 1 to 5. 1 to 5. All right? So when I reach down here, I would equal to 1 plus 1. 1 plus 1 is 2. So you're going to go back up and check again to see if I reach to 5 yet. Right? So you say when it come down, remember that I was 2, so you're going to say 2 is equal to 2 plus 1. So that is 3. So you're going to go up again and ask again. When you come back down, it's going to be 3 is equal to 3 plus 1. So that is 4. You're going to go back up and come down again. So you're going to check to see if it get the 5 yet. Don't get the 5, we're going to say 4 is equal to 4 plus 1, which is 5. So you're going to go up here and you're going to see that it reaches 5. So it won't go any further. Right? But if I put 1 million right here, you're going to continue. If I put more than 1 million, it will just continue on and on and on and on. I will never stop.
All right. So over here, you use the dotted line and then come up. All right. So over here, this is how we do the looping until we reach n values, whereby we will do the last time. And when we go up, when we have the I which is beyond the n value, it will come out.
And then it will stop. It will stop
so
our print out.
We can draw it this way. After it is out, we need to do a process to find the average. So AVE is assigned with sum divided by n. And then, after that, we can be able to show the output. So output would be, all right, average is AVE. And finally,
one link.
I think by now, you might be able to see what do you call that, one error. Okay, we have I is equal to I plus 1, which is not visible over here. So that's a problem over here, which we have to do. Now I can do this by doing I plus plus over here. All right, but as we mentioned, flowchart or algorithm shows step-by-step instructions. So if we have to add this over here, then this I plus plus would be step 9. And then this step 9 would be step 10, and then the changes have to follow through. So you would have to do that. So with this, you are supposed to make the changes, all right, of this, what do you call that, difference over here. And still, we have one more problem, all right? We still have one more problem that is not solved, all right? I will not solve it over here, all right? I will leave it to you. So I'll go straight to the programming. Now, in the programming, we see that we have quite a number of variables. So let's start with. So that's a problem.
So we're gonna stop it right here, and then we're gonna take a break. And next week again we're gonna look at this looping, because the looping is a lot of persons don't catch looping so fast. So you catch the sequential structure, you will catch the selection structure, but the looping structure it usually give a lot of people some problem, right? Even when you're writing the code for it. When you're writing the code for the looping, it usually give a little trouble. Because some person they don't know when to write the for loop, the do loop, the while loop, the do until loop, right? So you have a lot of different keywords, right? So we're gonna look at the looping next week.
I will even have to watch the video again to learn it more.
Yes. All right. So I'm gonna stop the share right here, and I'm gonna stop the recording right here.